and around 10 or 12 we'll switch again. Alright, here we are with our first equation toward bingo. Those who are playing at home can let me know what you're getting. You can make your own bingo sheet or pull out the back of the one that what we were using yesterday. Here we are, and I have a situation where, in purple here, the projectile is being launched, so draw it as I describe it, 95 feet per second, and it's launched at 25 degrees, and it's in projectile motion. Find the maximum height. I promise you'll see one of those tomorrow, so let's make sure we get that down. So go ahead, people at home, try this one. 95 feet per second is the initial velocity, 25 degrees, find the maximum height. It's always amazed me that you don't really need to know very much in order to find the height that the projectile goes. Ignore my blab if you're working along, but first thing you ask yourselves is this a question in X or Y? And of course, maximum height is going to be measured from here to here, so it's going to be a question in Y. So I'm going to start down my list with all the values in Y in any order. So if I'm looking at this in Y, I'm going to fill these in without speaking, so try to fill those in without relying on me, and then look up and see if you agree with mine. I have my list. If you want to check midstream, check against it.
That should be 32 feet per second.
Oh, we're in feet. Ooh, yeah. I wonder. Yeah, the number's right, but just the feet. Thank you. Check against mine now. And we don't know time. So let that be your guide. You need to come remembering the three equations. I'll write them up for now. I observe what I have and what I don't have, so I'm going to go to this wall, the second equation, because that's the only one that doesn't have time. So I'm going to go there. Did you get to that equation before I did, hopefully? All right, I'm about to reveal the answer. Are you ready?
No.
All right. So if you use the list the way I did you get 95 sine 25 to be 40? Alright, so that works. Everything else is just given or understood, and I put in the squall equation. Remember, final velocity at the maximum height, there's no y component, so we have 0 equals the initial velocity in the y direction. This is all in the y direction. And we're going to get 40 plus 2, negative 32, as we're working in feet. X is what we're looking for. So solving that, did you get 25 feet?
Yeah.
Alright, if you got 25 feet, you may cross out G2. Alright. Will you be able to do a maximum height problem tomorrow?
Yeah.
Think so? Alright, we'll put that one to rest then. And we will not. Any questions before I erase it? Emily, number 1, you okay?
Yeah, I'm good.
Alright.
I did 32 divided by 2.
Instead of times?
Yeah.
Alright, get that out of your system. It's gone, okay? Alright. Alright, this one, I don't know if I'll get much bingo out of it, but I do just want to discuss how to begin this one. And that one is, say you have 3.2 meters per second. I'm going along at that rate, at this angle, for 2.1 hours. Long walk. Then, I'm going to keep the same speed and just change directions for another 3.1 hours. So, I'm on the Appalachian Trail, so I walk all day. Find the displacement, so the final displacement. This is the long, 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 long one. And I'm not going to take time to do it now, but I am going to take time to discuss it now. So, could you, just going around to Robin again, could you tell me, if you were given this information, what would you do first? Because basically that's all that's going to be in front of you tomorrow. So, Emily, number 1, what do you do first? There are choices. What would you do first?
Convert hours to seconds.
Alright, you want to do a check on the units. So this is meters per second, but it's in hours. So we're going to switch hours to seconds. So how do you do that, Emily?
Multiply it by 62 times.
62 times, right, which ends up being 3,600 times 2.1. And then you do the same for that. Emily, number 2, what would you do next? You've got the right units now.
Then you use your first part of the voter.
Alright, why don't you use the whole thing? She said
Because
use the first part.
Acceleration equals 0.
Right, because we're going at a constant velocity. So we know we know initial velocity, and we know time. It's in seconds, so we can get displacement. All right. Then we have a number with an angle and a number with an angle. So say this came out to be 1600 at 115 degrees. So I'll just write it like that. And this came out to be, this was longer, so I'll say 1700. I'm just making this up, so don't check it. Alright, say Hunter, we did that, and she used the part of the voter equation and got actually displacement. We don't have velocity anymore, we have displacement at angles. Then what do we do?
Well, then we do X and Y.
Right, right. Alright, you get the same question. So which trig function is for x again, and which is for y?
Y is sine and
Right.
X is cosine.
Right, so you're going to do this, cosine this to get the x component, this sine this to get the y. And then do the same down here, this cosine this to get the x, this cosine this to get, sine this to get the y. Then what, Emily, number 3?
And then you add the X's and add the Y's.
Right, and then Zach? So we end up with an x and a y. Say we get, I don't know.
Square it.
Say we have 52x and minus 71y. I'm totally making that up.
You would Pythagoras.
Pythagit, okay? So Brian, after he Pythagit, he's going to take these numbers and Pythag them. And watch when you Pythag that negative one. Some people end up with a negative value combining with this value. This is always going to be a positive value. All right, Brian, what happens after we Pythag it on this long road to recovery?
Oh, I'm not at the point yet, but when you use the Pythagorean theorem for that,
We're saying the x component, once we added the two vectors, was 52 and the y was minus 71. So,
how'd you get those two vectors?
Pardon?
How'd you get those two vectors? Because I got,
We didn't, we just made it up.
oh, okay.
We didn't
Well,
feel like
52 times, or 52 squared.
Well, I don't care what it is, I just want to know what you do next with after
You
you
use
Pythag.
an inverse tangent.
Inverse tan, right, so inverse tan. Which value goes on top, Brian? The x or the y?
The y.
The y over the x. And lastly, the last step, all the way back to you, Emily number one.
And you adjust,
All right, and how do you adjust?
by, if needed, adding either 180 or 360.
Now, how do you know what quadrant you're in if you don't have the angle? Well, you have an angle, but you're not sure. Where do you look on all this work to find out what quadrant you're in?
The angle is
Pardon?
210 and 115, the angle.
Oh, yeah, but well, that's after you add them, it's kind of hard to know what quadrant it ends up in.
You can draw. I mean, it's a
You could draw it, but sometimes it ends sort of questionably. So there is a spot that's reliable that you can look at. Do you remember? Emily number two, where do you look to find out what quad? Because you know, you know
Oh, sorry, go ahead.
where.
You look at the x and y.
Right,
It's
this-
y is negative and x is positive.
Oh.
So that tells me I
so
went up and
x
then
is
down.
positive, so it's over here.
So what
and
quadrant
y
would that have
-4.
been in, right? So we would have had to do what if this was really the answer?
You added,
360, right, because this would be, so Emily, number one, is that clear why we look
Yeah.
here? All right, if they're both positive, the one's negative and the other's positive, tells us where we are. All right, so it almost took as long to talk about a fake one as if it would to do
I'm
it.
doing the bag right now.
Oh, thanks.
I just wanted to make sure.
Okay, very good. All right, we're not really going to do any bingo on that one. I just wanted to discuss it and not even really do one.
So you don't.
What quadrant did it end up in?
3.
Quadrant 3?
It's
Okay.
41,000 at 175.
That's what I got. Well, for 41,000, I didn't do that one yet.
Very good. Thanks for working it out. All right, let's do one with the range equation. Notice it's off the board, so you're going to have to come up with it. So say that I shoot a gun.
What was the answer?
175. 41,000 at 175. What? 15?
I shoot a gun and its initial velocity is 210 meters per second. I'm shooting at 20 degrees. Find the range. Find the range. The gun is shooting at 210. And this one we will do a bingo for. So 210 is the initial velocity, the angle is 20, and I'm looking for the range. So I'm assuming that the bullet is doing that. So we're allowed to use the range equation. Are you in degrees, people?
Oh,
Wait.
yeah.
It helps.
Yeah, I mean,
You
So,
always gotta change
two
it
sig
around.
figs, you have the
It
answer,
sucks.
and two sig
I did the
figs.
whole entire first part of the review.
Ingredients.
You
Weren't you
want
getting some weirdo answers though? You get like
Well,
negatives and
the
things.
only one that I did that for was for 6, and I didn't understand it. I don't know why I didn't think of
Good to check it.
just 2 significant digits.
2?
Right?
Yeah, we'll do 2.
Wait, I'm not ready yet.
So, Ms. Powell, in the previous problem, you would take the cosine of both components and add them together, right? And then you would take the sine of both components, put them together,
Yep.
and then you would use the Pythagorean theorem on both of those answers
Just
to get the
Yeah.
length of the final vector.
yeah, the final one. Yeah.
And
Yeah.
That was 41,000.
Yeah.
So I
Yeah,
got
what'd you get, Zach, again?
Like 40.
41,000.
So I got like 45,000.